season starts here, the Vancouver Boat Show.
Welcome to the Vancouver International Boat Show virtual seminar series, sponsored by Freedom Marine International Yacht Sales, the premier choice for exploring the passion of yachting. Thank you for joining us. The seminar will begin in one moment. If you are having technical difficulties, you can reach me, the online moderator, via the chat feature at the bottom of your screen. Questions for the speaker can be added to the Q&A box also at the bottom of your screen. We will answer these at the end of the presentation. Now it is our pleasure to present Marine Weather 101 with Ross McDonald. Ross, thank you for joining us.
Yeah, thank you so much, and thanks so much for the introduction there. Welcome everyone, and thank you for welcoming me into your home, your space, virtually. Welcome to my space. I'm at home here as well. So it's a whole new world here with the virtual boat show conference, but I think we can certainly make it work and have some fun with it too. So thank you for all joining for this talk today. It really is a talk that we've done a few years in a row now, tailored it and streamlined it a little bit, but it really is aimed at kind of new boaters out there who are need to maybe learn a little bit about how the weather works, where to access our marine forecasts that are for the West Coast here. And just some tips and tricks that hopefully I can help you with. And of course, if you have any questions, again, we were happy to answer them at the end here as well. So just a little bit briefly about myself. I'm a meteorologist with Environment Canada, and I work at the office in Vancouver. And I've got about a dozen years or so of marine forecasting experience working at something called the Pacific Storm Prediction Center, which I'll get into in a little bit. But that's basically where your marine forecasts are produced, and so those forecasts are produced 4 times a day. They're out looking at about 5 days. And it's basically a marine desk that produces them, and then that desk is staffed 24/7, 365 days of the year. And even during the pandemic here, while most people, a lot of the non-operational staff are working from home, operations remains fully staffed, and people are still going into the office with proper physical distance measures in place there. So the pandemic is on, but we're still able to roll out and produce forecasts, for you guys as well. So it's a little bit about me, just a little brief bit about it. So I would invite you in most years to come to our booth. And this, in a normal year, is what it would look like. But here we are doing what we can in the pandemic. And so I would encourage you to please come and visit our booth virtually. There's lots of great stuff on there. It's been put together by a fellow, Mike Gismondi, and he's there as well as myself, that if you engage through the chat, that we'll be happy to answer any other questions that you may think of perhaps after this talk here as well. Lots of good stuff. So you can chat with us. There's some great material that we would usually hand out to you in person and be able to talk with you in person. But one of them that I like to highlight, there's a few things going on here, including the BC Marine Regional Guide and Met 101. What I like to highlight is this this kind of weather services sheet. It's kind of a one-stop shop. If there's one thing I would say, go to our page, download this. It's fantastic. It kind of gives you a lot of the different stations, the different buoys that are out there in both the inner South Coast waters, as well as right across the west side of Vancouver Island up into Haida Gwaii. So please visit our booth virtually, and I would highly recommend looking at downloading some of this great material that we've got for you there. So it's a little plug for the booth. The Pacific Storm Prediction Center, where your forecasts are made and produced, again, 4 times a day. This desk is staffed 24/7. This is just a photo pre-pandemic, of course, but we're looking at a couple of forecasters, and this fellow over here, Louis Louis Kohani is one of our best marine forecasters there. He's working hard at the desk, but lots of computer screens, lots of data coming in that we're looking at, weather models, but all sorts of satellite and radar and buoy observations, surface observations, which we'll get into in a little bit as well. So it's a big operation to try and get the weather right for the West Coast here. So it's a little bit a brief intro, but what we'll talk about today, and again, it's just really the basics. We just kind of give you a flavor for everything, a nice introduction, and again, if you have further questions, we can try to answer those in a bit. But we'll kind of get into just the basics of what causes wind. How do we really measure wind, and what wind are we talking about in some of our forecasts? And we'll get into this. The brief bit on the effects of terrain on wind, and certainly we're no stranger to a complex terrain pattern here in BC on the West Coast. We'll get into a little bit of waves, and then just touch on the different types of wind warnings that are out there. And finally, just kind of we'll take you around the Weather Office page, which is kind of where your marine forecasts are and how to get at them, as well as some of the data that we'll talk about in terms of how fast the winds are going at different stations or buoys or anything like that. So we'll start off with what causes wind. Really just we're talking about a difference in pressure. A couple of forces that impact the wind, but one of them is the pressure differential between high and low pressure. Wind will blow from high to low pressure. Pretty simple. Now let's add the Coriolis force. And at least in the northern hemisphere here, it's going to deflect everything to the right. So you've got this general pressure difference, which we'll call a pressure gradient force, a little fancy word. And then we have the second force, which is the Coriolis force here, which is going to deflect things to the right. In terms of, we talk about the difference in pressure and the strength of the wind. If there's a stronger pressure difference or gradient, the wind will be stronger. If there's a weaker pressure difference, the winds will be weaker. So what I'm just showing here is just kind of, it's probably perhaps something you've seen with the evening news, or the evening weather, or the Weather Network, or it's just kind of a weather map showing lines of equal pressure. And these are the black lines there. And so you can see up here, we've got an area of high pressure. And then we kind of come down to the eastern seaboard, and there's this L showing an area of low pressure. And these are equal lines of pressure. And the difference, or the strength of the wind, is really dependent on the difference in pressure. So the tighter these lines, the stronger the wind. The weaker the winds are areas where that pressure difference is much, much less. So those lines are much, much further apart. So a shallow gradient. So weaker winds up here, but these lines are nice and close together. That's a tighter pressure difference, tighter pressure gradient, stronger winds. So that's really kind of the driver of wind is the pressure difference. The stronger the pressure difference, the stronger the winds. And so you put the two together, and it's basically, again, the Coriolis force helping to direct things a little bit to the right, at least in the northern hemisphere. And you kind of come up with this kind of simplified diagram of low pressure, things kind of spinning into it, spinning, going certainly a little bit counterclockwise, and then you've got the other way, you've got the high pressure going clockwise. So that's just very, very basic kind of pressure difference for winds, stronger pressure difference, stronger the wind, and the Coriolis force kind of deflecting it to the right, at least in the northern hemisphere here. In terms of how we measure wind, this is not an official instrument, but it has the right idea to measure wind. What the instruments that we measure wind with are called anemometers, and there's various types. If you come to our booth, hopefully we are live and in person next year, but in past years we have had anemometers from buoys that have had better days that basically are non-operational, and it's because of significantly strong winds. And so they're kind of fun to look at. You can actually see the equipment up close, and kind of get to feel and just see the size of it. But for now, we're just going to have to do with pictures. And so there's kind of two main observation or ways that we'll talk about measuring wind. And the first is with buoys that we have on the water, and we have several of them around the inner south coast waters, as well as the west side of Vancouver Island, and again up to Haida Gwaii. And we measure those winds at 5 meters above the surface, or above the ocean surface there on average. And then we have the WMO, the World Meteorological Organization, has set 10 meters to be the standard height where winds are measured in land-based stations. So it's going to get a little bit, you have to kind of think about where you're measuring the wind, but typically the higher you go off the surface, the stronger the wind is going to be. The closer you get to the surface, the weaker the wind is going to be. And that's going to play into how we look at what winds we look at with respect to buoys, because with them being a little bit closer, where the wind measurements are a little bit closer to the ocean, typically we're going to need to try to account for that difference. Again, we want to try to compare apples to apples. It's not quite, but so there's a little bit of a conversion factor in between the apples of land-based stations and a different kind of apple, perhaps, for buoys there. So there's a little bit of a conversion there. The other thing that buoys that's a little bit challenging is that they can sometimes get caught in the trough at the bottom of a wave, and you have winds that are blowing, 30, 35 knots, but perhaps they're not being picked up as much as they should be if it just happens that these buoys are in the trough of the wave, and they will not be detecting the strong winds because they're rather sheltered within their own waves. These are things that we, again, need to adjust for and need to account for. But it's just another little wrinkle when we're talking about what wind we're measuring. Again, land-based stations are at about 10 meters high. Buoys, 5 meters, and then sometimes you get caught in the wave crest, and it can really affect the measurement. Ship versus buoy anemometers. Again, it's one of those things that, generally speaking, the wind speed will increase with height. So what am I showing here? I've got a picture of a boat, rather large one, and it perhaps has wind instrumentation that could perhaps be measuring up near 30, 35 meters above the surface. And then you've got the buoy down here that is only at 5 meters. And so this kind of chart across the right-hand side with wind speed across this bottom horizontal axis, and the height across the vertical. We do get it at times. I'm not saying that you're going to be out on a big tanker or BC ferry, even perhaps large vessel of that nature, but we do get reports from folks out there who are saying it's blowing 30, 35 knots, for instance, and for some reason the buoy that perhaps may not be too far away is only reporting half that or significantly less, maybe 20, 25 knots. And really that has to do with where the wind is being measured, and sometimes we do have to kind of talk to the folks out there and just say, okay, what is the actual height where you're measuring the winds at? And this may actually account for why there's a discrepancy there. So the height and where you measure matters with respect to the wind there. So which wind is now, we've talked about the different types of instruments that look at wind. And again, we've got their land-based stations, which are at 10 meters and measuring wind. And then you've got the buoys at 5 meters. But what wind are we actually talking about when we're talking about forecasts? And this is I captured this from our forecast yesterday. And so what I've got here is we've got the Georgia South Nanaimo forecast, and we've got some winds mentioned of 15 knots and 15 to 25 knots. But what are these winds? Well, these are what we refer to in the forecast as the sustained wind. What is the sustained wind? Rhetorical question. Don't worry, it's coming next slide. So keep the word sustained wind in your head. And now we're going to look at an observation. This one's coming from yesterday from Herbert Island. And I kind of chose this one purposefully because we're looking at the wind measurement. And now we're looking at these winds here being measured are 18 gust 25. So what is 18 gust 25? What are these winds that are being observed? What is that? And again, Herbert is a land-based station, so it's at 10 meters. So it's measuring these winds at 10 meters. It's 18 gust 25. Well, 18 is referred to as the sustained wind, and the 25, as is shown in the observation there, is the gust. Well, what are these? So keep in mind, sustained wind, Herbert there is 18 knots. The sustained wind is something we take as the 2-minute averaged wind. So we've got Herbert, and it is the station is sampling the atmosphere. The anemometer is going do 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 do, and it's coming up with all this data. And so what we've got is a chart with time across the bottom in seconds, and we have wind speed across the vertical. Okay, so we're sampling every single second here, boop, 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 in the gray, and then we take the 2-minute average of that to get the sustained wind, and that's the green line. So you'll see that although some of the peak winds, some of the strongest winds, the 1-second instantaneous wind there is significantly stronger than what we're calling the sustained wind, we've kind of just smoothed that out to get this kind of to get this measurement of what we call sustained wind. And that's what we are forecasting for. So keep that in mind. And I'm just going to go to the next one is the gust. And again, at Herbert, we saw 18 gusting 25. So 18 was the sustained wind, 2-minute average. What is the gust? The gust is the 5-second average. Same chart. And we've got the gray line again. This is the 1-second instantaneous wind, do, 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 do. And now the gust is in blue, and it's a smoothed out 5-second averaging. So again, even the gust is not showing the highest peak of the instantaneous winds. It's close, it's better represented, but it's not quite showing the exact peak winds. So this is all to say that the winds that you see that are forecast, and we do those forecasts for sustained wind for 2-minute averages, and the gusts, which is the 5-second average, sometimes you may see winds, even if you're hanging out at 10 meters, where the stations are sampling, you may see winds that are stronger than that. You may also see winds that are weaker than that, which is even indicated here, just a slightly weaker peak winds. But again, that's kind of smoothed out with the 5-second average there. So it's an average. It's close in terms of the gusts every 5-second, and then the sustained wind is the 2-minute average. So just something to keep in mind there. And then you have the buoys, which are 5 meters above the water sampling, and you have all the trouble or the challenges with the difference between the land stations and the buoys. Not just that they're sampling at different heights, but that they're potentially going to be not, again, sampling at different heights, they're going to be recording slower speeds, but buoys may, again, as we've seen in the diagram earlier, may report lower wind speeds because they get into the troughs of those waves. So therefore, we need a slightly larger sampling size. And so the buoys actually take a larger window to get that averaged wind speed, to try and, again, smooth out those kind of the details of where they might be in the trough, or they might be riding the crest. So it's a little bit of a longer average that's taken. And because that, and it's just a little bit of a technical thing for us when we issue the particular marine wind warnings, but we actually take slightly lower thresholds because of it, because of, as we say, the buoy is a little bit lower. It should probably be under-reporting the wind somewhat. It could potentially be impacted being in the troughs of some of the waves. So we actually have our slightly lower threshold when we say that we've hit a gale force wind, or we'll talk about later a storm force or hurricane force. We have slightly lower criteria because of just where the buoy is sampling there. That's just something to keep in mind there. So terrain. So we've talked about wind and how it's generated, pressure gradient, Coriolis force. We talked about measuring wind and sustained wind, the 2-minute average, gusts, 5-second average, winds generally on the land being measured at 10 meters, buoys at 5. So the impacts of terrain are significant, and we can only really touch on them here. And I would say if you're really curious and keen, again, we've got some fantastic material on our booth page. The Marine 101 just goes into a wonderful bit of detail. I'll give a shout out to, he's no longer with us, unfortunately, but a great marine forecaster, Owen Lang, who wrote The Wind Came All Ways and did a lot of research and work on marine forecasting, which is kind of the Bible for marine forecasters. It's one of the things that's read when you first start training on the marine desk. And so his influence, he's still impacting marine forecasts and marine forecasters for even though he's left us. But his work has been captured in some of the documents that are available to you at our booth there. So certainly go check those out. But we'll touch on just terrain just briefly here. And the Strait of Georgia, Juan de Fuca, the south coast of BC, we live in a truly beautiful part of the world. We're very, very lucky. But it's not without its challenges, with steep mountains across the spine of the island, and of course on the coastal and Cascades here on the mainland. All sorts of different inlets that we try to capture for, but in all honesty, there's just so many of them. It's hard to get them all. And so we have the main predominant kind of southeast to northwest across this Georgia, Strait of Georgia here, and the kind of east-west through Juan de Fuca. But then, we do have these little variations of, sometimes the wind kind of likes to hug the north side of the mainland side here, or perhaps when for Vancouver here, where my cursor is, we'll get a sea breeze, typically, in the early afternoon. A fun one, which I've got a couple of cool images to show, is the qualicums that can funnel out and can cause a little bit of havoc. They can be very, very subtle when they happen. They're sometimes not covering a large area, but they are impactful. So all these need to kind of be, or attempted to be, taken into account here, and we try to do that. So, just kind of, again, a lot of inlets, channeling of the winds, a lot of areas for unique meteorological kind of conditions to happen. And so it mentioned the qualicum winds. So what am I showing you? Okay, on the left hand side here, I've got something from our high resolution computer model, and you can see where my cursor is. You can see the winds kind of spilling out, and kind of this quick burst of kind of west to southwest, and spilling down through Georgia, the south, the north end of Georgia into the south here, and it's abruptly cutting right through, and then just to the north you've got the northwesterlies that are spilling down through Sentry Shoal and heading towards the south here. And we have a station up here that was capturing it. This is kind of a real satellite data, but capturing the northerly winds, which are these ones here in the yellow. But then this little kind of brighter patch of yellow and orange, or yellow and green, is showing kind of the burst of these qualicums that are coming through. Not captured by a station here, but they're there, and they're and certainly significant when they do happen. So they're again very, very subtle features that do happen with around our inner south coastal waters here. But the qualicum is a more common one, especially as we get into the summer. And just kind of more weather eye candy. This is again taken from satellite. We have little observations in these kind of green kind of wind barbs here. But the cool thing to look at is this is kind of a very slack weather pattern. Not a lot of pressure gradient. It's not a lot of winds, but even subtly here, you can kind of see a little circulation off the west side of the island, and just a very, very subtle little low pressure system that's there. It's being picked up a little bit by one of the buoys here, but it's again the kind of the intricacies of the weather there being picked up, and sometimes we are getting more of these kind of tools, these with satellites to kind of help us out. We probably like more of them, but again, the subtleties of trying to get the weather right. Mother Nature's always throwing us curveballs, lots of challenges for sure. This is just a brief kind of summary to kind of sum up a lot of the winds. But again, different heights. Talked about this. Land-based stations at 10 meters, buoys at 5. Different averaging periods. Again, our forecast, when we talk about a wind that's 15 to 25 knots, we're talking about the sustained wind, and that's a 2 meter or a 2 minute average there. And it's at the end of the day, we are trying to use the observations that we've got to assist us in the forecasting. It is kind of a meshing of reality, and then we're trying to get it right. So that's kind of the picture with wind and how we measure it, what are we measuring, and a little bit of the impact of the terrain. I just want to touch a little bit briefly on waves. Hopefully you don't get caught in something like this, or maybe you do. So just briefly on waves, and we do, as part of our marine desk, provide wave forecasts, not for the inner south coast waters, but for all the other waters. So the west side of Vancouver Island, Queen Charlotte Sound, and up into Haida Gwaii. So we do provide wave forecasts there. And so just a little bit of wave basics. Kind of top of the wave, we've got the crest and a little bit of a wavelength here. And then at the bottom, we have the trough. And from the trough to the crest is what we call the wave height. So for forecasting 1 to 2 meter waves, from the crest to the trough is really what we're expecting for that 1 to 2 meters. That's what we're meaning by wave height. And again, they're measured by the buoys that we've got, and as well as a couple of other different bits of data they're able to get in terms of maximum wave, the wave period, as well as what they call significant wave heights, and we'll get into that in just a sec. So wave terms, we forecast something called, when we see a wave forecast out there, and again, it's maybe 2 to 3 meters increasing, we're building to 4 to 6 meters or something. We're forecasting the significant wave height. What is the significant wave height? A sample size of, say, 1,000 waves go by. The significant wave height is you take the third of the waves that are the highest out of that entire sample size. So one wave after another is going by a buoy, and they're picking up the wave height, boop, 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 boop. So 1,000 times that's happened. Now we're going to take a third of those waves, and those third of the waves are the highest third, and we're going to take the average of that highest third. That is the significant wave height, and that is what we forecast when we do our wave forecast. It might be a little bit difficult to understand, at least at this point, but I'll show you an image too that hopefully can clarify it a little bit more. There's also something called the peak wave height, which is the highest peak wave expected. And generally, it's a kind of a rule of thumb, but we can calculate this with the significant wave height double, essentially, is the peak wave. So, significant wave height. What you're seeing here is a kind of a distribution of different wave heights that would have perhaps gone by a buoy. Again, boop, boop, one after another. And they're being sampled here. And so we've got the wave height across the horizontal here, less wave height or smaller waves on the left-hand side and the biggest waves on the right. And the number of waves is kind of across the vertical. So the significant wave height that we measure, we take the third of those highest waves, and then we take the average of that, which is here. And then if you take the basically double the significant wave height, you get the peak wave. So how is that going to translate that? Because that is essentially our wave forecast. Well, let's look at one that we picked off yesterday. We've got, oh, it's a good one too. 3 to 5 meters, building to 5 to 7, even going to 7 to 10. That's a doozy. So we've got, those are the significant wave heights. Again, of the third highest waves that go by, say in 3 to 5 meters, 3 to 5 meter waves, a significant wave height, the third of those highest waves that go by, that's the average of those. So if we say we pick off, say, 5 meters, let's use that as an example, and we've got a given significant wave height of 5 meters, that may be that our peak wave is now double that, is at 10 meters. So one wave in 10 might be 5 meters, and then one wave in 1,000, the peak wave height is going to be 10 meters. So when we talk about significant wave, or we talk about our wave forecasting, at least, again, we're talking about the average of the highest third waves. So in many cases, a lot of the waves may be less than that. That is true, but we kind of want to steer on the side of putting in, what we defined, at least in the World Meteorological Organization, as significant. And so again, a lot of the waves you might see are a little bit less than that, but again, every now and then the peak wave goes by and it can actually be double that. So it's a little bit of it's a balancing act to try and actually pick a number. But if you're out on the water and you're seeing a wave forecast of that nature, and you're seeing waves that are less, well, just wait a little bit, it'll pick up, is kind of the idea. The other thing that the buoys do measure is the wave period, and the wave period is kind of measured as, the time it takes for the wave to kind of travel one wavelength. So it's kind of, crest down to trough, up to crest. So it's crest to crest is the wavelength. And so let's take an example that, what if the wave period is measured at 6 seconds? And this just makes the math easy. Then on the water, 10 waves pass by every minute, right? 60 seconds in a minute, which means that 600 waves pass by every hour, or 1,200 in 2 hours. And so if a peak wave frequency is happening kind of every 1,000 waves, that given a wave period of 6 seconds, you should probably encounter these 1,000 waves. It's actually 1,200, but we're being a little approximate here. But you should be encountering one of these peak waves, perhaps one of those 10-meter waves in our example, every 2 hours. So that's kind of how you can kind of figure that out and read that. So just touching on a little bit of terminology in terms of the different types of wind warnings. We've talked about wind, we've talked about how we measure it, we've talked a little bit about waves. the wind warnings that are out there, and I'm sure many of you are familiar with this, but I'll just kind of go through it anyways here. We have our strong wind warning, which is the first kind of first lowest threshold of warning, and that's kind of at 20 to 33 knots. And it's really only issued really during the spring and summertime, and I guess early fall there as well. So yeah, I don't think you would see these right now, but in about a month's time, you'll probably start seeing these through the inner south coast waters there. Stepping it up a little bit, we've got our gale force warning, and this is when we expect sustained winds of 34 to 47 knots. We go to our storm force warning, 48 to 63 knots. A lot of the low pressure systems that we'll see come by, they'll come off towards the typical track is usually the central or north coast, especially in November, December, good storm season there. And it's not uncommon to see as soon as the low is winding itself up, it's just, let's just go storm force. And it's basically storm force from northern tip of Vancouver Island all the way through Haida Gwaii, usually with these ones. So storm force warnings, not usually seen much here in the inner south coast waters, but certainly as you go up towards the central and the north coast, they can be pretty common in the fall and the winter there. And then the granddaddy of them all, the hurricane force warnings, and that's kind of anything over 64 knots. How common are these? I don't think it's uncommon, using the terminology, good weather jargon properly, but typically with good fall storms, you'll see it's not unusual to see the odd hurricane force wind warning out there for corridors, say again, the northern tip of Vancouver Island through to Haida Gwaii, through Hecate Strait there. Storm force is usually the more usual one, but it's not uncommon, I would say, to tip the scale into the hurricane force wind warning. So again, know your warnings here. Again, for a lot of us, it's really just going to be the strong wind warning, perhaps, that you see in kind of the spring and the summertime that you need to be kind of aware of. But that kind of completes the picture for all the different warnings there. So I'll kind of finally kind of talk a little bit about interpreting the forecast, and again, we can have a little bit of time for questions, and I can show, for those of you who may have been around the last couple of years and maybe come by our booth or maybe heard that we do have some ability to share high resolution models, and there's so much data on the web. And this is just another source, but we do have this available for you to look at, and I'm going to provide the link and the password at the end. But in terms of, we're looking at a marine forecast, and maybe you're looking at some marginal gales. Let's, just for reference, we'll put Vancouver and Victoria just with the stars. And let's focus on this little blue area here. And that's 30, on the scale here, it's 30 to 35 knots. Essentially, it's borderline gale. Well, what does that sometimes translate into for the forecast? And that sometimes usually what we call a marginal gale, and that's usually written as a 25 to 35. And sure enough, fantastic as the weather works out, there was an example for me to capture yesterday. And so just going back, we've got 25 to 35 knots kind of in the northern side of the Strait of Georgia, but so the forecast is written kind of 25 to 35, but where they are really focused on is really just north of this is Texada Island here. And so when we write a forecast, the north of Georgia, it's a very, very broad area. The peak of 30 to 35 knots was probably limited to Texada, but the whole forecast is captured as a gale warning. So our forecasts, at least when we write them, are generally fairly broad. We'll, of course, err on the side of caution, But if there are specific routes that you're going and you want to know specifically about a route, a plan that you're doing, you can give us a call and we can give you one-on-one consultation. And that's available. Again, that's a service that's available at the Marine desk there. And I can provide the number at the end as well. But we can get specific with that. So our forecasts are generally fairly broad. But so if you're looking for the more specific ones or a specific forecast, we can provide that with the Marine consultation desk. But just kind of getting just around, just kind of typically as a little walk through our website. And if you're new to marine forecasts or boating, just kind of take you around. You go to the weatherec.gc.ca. There's your marine tab. Click on that. You get to this page. You can go, of course, off to the East Coast if you'd like as well, or the Arctic, but we'll pick the West Coast here. And again, this is, I think, from yesterday. So let's focus on the Strait of Georgia North. And we'll kind of look at a forecast here. And again, this is the marginal gale, 25 to 35. So you've got your forecast there. And you've also got today and tonight. And then you've also got your forecast that goes out another 3 to 5 days just across the right here. So we do basically 5-day marine forecast. If you're looking for the weather conditions, there's a tab that right here that you can click on. You'll take you to this page, and you've got the different buoys on the water in red, and you've got the land-based stations in green. So you can click on one of these land-based stations. I think I've selected Sisters here. And you've got different data in terms of the wind and pressure, even the sunrise and sunset to complete everything there, and air temperature as well. If you're looking for past 24-hour conditions, those are also available. So there's a lot of information here. So you just click that and you can be taken to this page here, and you can see the last 24 hours of observations of wind, as well as all the other data as well. Just going back, sometimes we've had requests of where the lighthouse reports are. They're right there. So it's not exactly, sometimes it's a little bit more hidden. We've had some complaints about that, but just to show you, that information is there as well. And in terms of how our forecasts read, this is sort of the way, in terms of the jargon, you see winds that are strengthening or winds that are diminishing at this time frame or at this time frame. And so we define them as basically morning is 6 to noon, afternoon is noon to 6, evening is through to midnight, and then overnight is midnight to 6 a.m. with the early and the late kind of being tagged on for the littler 3-hour blocks. So if you're reading a forecast, it's generally straightforward, but there is a little bit of specificity for what time period we're talking about. So again, if you're seeing late evening, we're certainly talking hopefully 9 p.m. or afterwards there. So if you do want to get in touch with us, one of the things we want to, of course, get out there is that, if the 5-day forecast, you're planning a trip that's beyond 5 days, give us a call. If you're looking for a specific route, give us a call. We're happy to try and lend a little bit more of a specific forecast and tailor it to your needs. And so we're available, most days 5 to 9 p.m., 5 a.m. to 9 p.m. And that's a free service. And then on the weekends and holidays, it's 6 to 6. And so again, 1-900-565-6565. I put it out there as well. If you do want to talk to, if you're doing something non-marine related, planning your picnic or something, perhaps as we're all hoping to do after the pandemic here and get together. But if you're looking to have a forecast or speak with a public forecaster, there's also a line available for that. So those resources are available there too. Those numbers are also available on our booth page. So I'll just briefly finish up with, just kind of like a little, it's anecdotal, but it is actually fairly applicable, especially when you come to our weather. Deteriorating weather, you're out on the water, you're seeing any of these signs, the barometer is falling, lower pressure is coming in, typically lower pressure is associated with storms. You're seeing a high band of cirrus cloud approaching, usually indicative of an approaching frontal system, high level, that white ice crystal cloud. If you do start to see the shift to southeasterlies, this is usually indicative of at a storm approaching or a low pressure system approaching. If you're in the Strait of Georgia and you see southeast winds, that's usually the winds indicative of something ahead of the storm. So deteriorating weather. But on the other hand, improving weather. So high pressure is moving in. We've had a switch of winds to west to northwest. And that's usually, again, the low pressure system's gone past us and we're kind of easing off with the weather and so on. So I kind of will, I guess I'll kind of almost conclude the talk here. But just to say that there's a team behind you, a lot of meteorologists. This was well before the pandemic, of course, but there's a lot of people, and we're here to support you. We're here to, without you guys, we don't. You guys help us do our jobs. Like we need, your input on how we're doing, where we can improve. It's a symbiotic relationship between both of us that that can make hopefully a better marine forecast and ultimately help you and keep you safe out on the water. So I'll kind of end it there with just one couple of links that I want to just kind of buzz market. The high resolution model that I showed earlier with the qualicums is available at that website there, weather.gc.ca/visaweb, and that's the username and password. We've given this out in the past, but only if you come to our booth. So I figure if you come to the talk, you should get some kind of candy at the end here. The other one that I'll push as well, and it's not, there's a word mountain in there, so it's kind of the opposite of marine weather, but it's a great, the resource that we provide, Avalanche Canada, is basically a daily weather story on what's going on. So if you want to learn a little bit more about the weather, it's a great resource. It's got weather maps, and it's hopefully more times than not colorfully written with some entertaining value, but a good description and a good tool to kind of get to know the daily weather. If you're looking for a weather story and a weather resource, that's a good one there as well at avalanche.ca/weather/forecast. So, with that, I think there's some questions, and I'm happy to try and answer those. So with that, I'll say just thank you very much, for your attention, and I'm happy to take your questions here.
Thank you very much, Ross. If you have any questions at home, be sure to drop those down into the Q&A box at the bottom of your screen. Not the chat box, but the Q&A box. All right, so starting us off here, David asks, is there a marine desk for the Great Lakes, St. Lawrence Seaway, and East Coast?
That's a great question. Yeah, so if you go to our web page, we're kind of showing, was going through kind of earlier there, and we kind of zoomed in on the West Coast, but there are other marine forecasts that are done right across the country, and that includes the Great Lakes, that includes the Arctic waters as well, which, as it may seem rather strange, perhaps, but we actually at the Pacific Storm Prediction Center in the summertime, we do the Arctic marine forecasts for everything basically west of Baffin Island. So it's a huge area of expanse, and of course, with more marine traffic in the area up there, those forecasts are becoming a little bit more important. So we even do a little bit up there. In the Great Lakes forecasts are done in the Toronto office, And then the folks in Halifax and as well as a weather office in Gander, Newfoundland, take on the forecasts for the marine waters on the East Coast. And of course, we have our own fun with hurricane force winds and storm force winds and rather strong low pressure systems. But they get the added fun with hurricanes that come by from time to time. So that's also where Halifax is also where our National Hurricane Center is located. So. But thank you for the question there.
All right, next up, if you were planning to cross the strait from Vancouver to Nanaimo in a week's time, when would you start to watch the weather, and what would you monitor to ensure a safe, comfortable crossing?
Wow, great question. It's probably worthwhile just taking a peek at our forecast probably 5 days out, and looking at the southern sections of the Strait of Georgia, and just kind of seeing what if there's any kind of, if the 5 day forecast, obviously it's out there. It's something that can be will be adjusted as we get closer to the event time. But it's certainly an initial kind of first look at things. And so if you're out there, and if you're, say, a pleasure boater, and if maybe your tolerance level is 20 knots, and you're seeing generally winds that are light in the day 5, then that's usually fairly, keep an eye, of course, on the forecast going forward, but that's probably a good sign. If you are seeing the kind of 15 to 25 knots, then it's maybe at that point just kind of monitor things for the next day or so. But of course, you're more than welcome to of course give us a call, and we can be a little bit more specific with it. One thing that we do is we do a lot of consultation with BC Ferries, and we do a lot of consultation with local tugboat and towboat operators, and sometimes their thresholds are very specific. You talk about the most significant storms that we have, and they can be, storm force, gale force. Sometimes those are easy. The subtleties of weather, you want the most challenging marine conditions can actually be the summertime. It's are we going to hit 15? Sometimes that the magic threshold of where people's tolerances are, and for some folks that can be 15 knots. So it's a little bit more. We can certainly tailor the forecast to whatever your threshold is there. So that's a bit of a rambling answer. I apologize, but
Perfect. Do you recommend using any apps such as Windy in addition to your forecast?
Great question. Yeah. So one thing I actually haven't talked about. We have a weather app with Environment and Climate Change Canada here. The reason I actually haven't mentioned it is because it's it's missing the marine component. It's really just good for public forecasts. So I don't, other than say, forecast for, say, Vancouver, Victoria, and Nanaimo, public forecasting wise, it's not really useful for marine forecasting. Windy.com, fantastic resource. And there are many out there on the web in terms of showing high resolution, very fine computer generated forecasts. Take them and use them, but do take it with a little bit of a grain of salt. I would say use it in conjunction with our forecast. Because I'll say this, they are good and they are getting better. And the clear direction where we're headed is basically faster computers, more powerful, and higher resolution models that are, just going to continue to get better. So it's a great resource. They look real. Sometimes they're not, though. So use it, but use it with our forecast, I would say.
All right. Mike asks, is there any plans to enhance your forecasts with maps and wind arrows similar to predict wind?
I've seen that. Yeah. It's that would be actually really, really cool. There's nothing imminent, I would say. I think there are some things that are being worked on. it's still the text-based forecasts, and a lot of that it has some history with it too, but it's something that we are kind of trying to move into more of a kind of showing weather with pictures, and if you go to, say, the Avalanche Canada site, you can see some of the potential, I think, that we could perhaps do for some of the folks in our marine website. So as of yet, no, but it's something that we're looking at.
All right. What is the best book you would say for marine weather forecasting?
Well, I would. It's the shameless plug of our own. Again, the ex forecaster who's unfortunately no longer with us, Owen Lang. He worked at the Pacific Storm Prediction Center for many years, and did a lot of research, and so his work has been captured in a couple of books, but one of them that I would recommend is, again, The Wind That Came All Ways, and it's focused on the Georgia Basin, so it's really the inner South Coast waters and the Strait of Juan de Fuca, and just the inner South Coast waters there, and the nuances of, say, Jervis Inlet, Howe Sound, just the little subtleties of where to perhaps expect the wind to curve and bank. Something that our broad marine forecasts, they're pretty generic, but the subtlety, the little local effects, he can describe quite well in his book. Now, the good news is, well, let me take a step back. In normal times, we actually have those books available at our booth. But of course, with the show being virtual this year, we're providing some, his material has been captured and is in those Met notes that's under the brochure section of our virtual booth. So I would say go there and download it and have a read. It's great material, and it's a great resource. So everything has been captured there. If you can find a copy of The Wind That Came All Ways, it's nice to. I still like the reading in a non-digital form from time to time as well. So it's nice to actually physically turn the pages. So The Wind That Came All Ways would be my recommendation. But don't worry, if you can't find it, go to our virtual booth, and the material is there as well.
Perfect. Why does EC not use the International Beaufort Force Scale?
Good question. That's actually, I'm going to have to get back to you on that one. I actually do not honestly know the answer. Why we don't, and the history with that. Save that question, and I will try and get back to you, or a colleague of mine will try to get back to you. But off the top of my head, I actually don't know.
All right, from Mary. Why have a username and password for website access?
Yeah, so for the speaking specifically of the Visa Web, so our website is non-password protected there. So the specific area, the specific part that is password protected is just this kind of, it's an experimental site, and that's kind of why we have it password protected. But the general website, where all of our forecasts are all freely available there. So the password is just more, it's because the Visa Web is more of an experimental site with these models. So that's why we kind of protect it a little bit there.
Excellent. Catherine asks, why is there a strong wind warning every weekend in June and July?
Good question. I guess maybe I wonder where which particular area you're looking at as well. There's, again, with the strong wind warning, we're looking at it's a seasonal thing. Looking at only, say, 20 knots or higher. How often does it happen? I'd have to actually go down and actually do kind of some statistics and see how often it occurs, say, in the Strait of Georgia, north, south, or Juan de Fuca. There's a typical kind of pattern that can form in the summertime where areas that are more prone to strong wind warnings might be the the parts of the eastern sections of Juan de Fuca Strait stations that like race rocks. There are certain conditions that they're places that can really see more frequent wind warnings there than others. So I need to know the specific area, but it just depends on the weather pattern. Sometimes it's just you'll get days after of just winds that may just tick up to 20 knots, and then you can get your strong wind warning there.
All right. Well, Ross, I believe that brings us to the end of our time here, but we do still have a lot of questions, about 21 questions still here in the Q&A box. So
Excellent.
if people do want to get a hold of you, is there any contact information that you want to remind us of to get those answered?
Yeah. Well, I would say if you've got your questions, we do have our virtual booth. If you could potentially, if it's not too much trouble, to ask them there if I haven't been able to get to them. And I promise that I or a colleague of mine will get to them, if that's okay.
Perfect. That works great. And is there anything else you want to add before we wrap up here today?
No, I think this has been really wonderful. I just want to say thank you so much for again taking time to watch and listen and inviting me into your space in your home. Welcome to my home, or my family room. And hopefully hopefully you can have a good rest of the boat show in virtual form. Please visit our virtual booth and of course be safe out there.
Excellent. Well, thanks again, Ross, for your time here today. And thank you all at home for joining us as well. We're interested in your feedback, either on this seminar or if you have any ideas on topics you would like us to cover in the future. So simply click on the Evaluate tab located just above the seminar description to complete the form. After the show, all attendees will also receive a post-show survey, so you'll be sure to fill that out. You can also check out all of the other features here at VIBS Virtual. And if you have any questions, check out the info booth for some answers. I hope you all enjoy the rest of the boat show. We're here for the rest of the week, so be sure to come on back. And once again, thanks, Ross, for your time here today. Thank you all for joining us. Enjoy the rest of your day.
Oh yeah, the season starts